Living on the moon might seem like science fiction, but NASA's Artemis program is hoping to make it a reality. The program's long-term goals include establishing a base on the moon, and possibly even using that as a way to get to Mars. That means it's time to seriously consider how we would live there. Not only does the moon have no breathable oxygen and no protection from harmful cosmic rays, its temperature extremes present a pretty unique challenge to future lunar settlers, which means any long-term moon base will need to be protected from dramatic swings in temperature. The answer could lie in taking a cue from our distant ancestors and setting up in caves. On Earth, our atmosphere insulates us from wild temperature changes, but the moon doesn't have that. That means lunar temperatures vary greatly throughout the day. When the moon is facing the sun, temperatures at the equator can get right up to a boiling 120 degrees Celsius at the equator, and at night, temperatures sink down as low as minus 130 C. That's a swing of almost 250 degrees, which is a problem not just for lunar explorers but also for the vital equipment they bring with them. See, most materials expand to some extent in the heat and contract in the cold. That's why roads in extremely hot or cold parts of the world tend to crack. Expanding and contracting puts strain on those materials, which can cause damage over time. Safe to say there are more challenges to building a moon base than in building your average road. But there may be a way over this hurdle, thanks to the moon's temperate caves. A 2022 study suggests that while temperatures on the lunar surface are extreme, lunar caves might maintain a more stable temperature. The team found this out from orbit, using NASA's Lunar Reconnaissance Orbiter. The orbiter is equipped with a thermal camera called the Diviner Lunar Radiometer Experiment. The camera scans the surface of the moon and sends what's basically a heat map down to Earth. To get the most out of this data, it helps to think about what it represents. In this case, the data is in pixels. We see an image, but each pixel in this image is a data point, averaging temperature across the area covered in the pixel. To determine the temperature of lunar caves, the team focused on a pit near the moon's equator around the Sea of Tranquility. Because the orbiter is also equipped with a regular camera, out 100 meters deep and roughly the length and width of an American football field. The pit also has an overhang on top of it, and from the camera you can see that it leads to a subsurface cave. So we have a thermal camera that tells us the temperature of the moon's surface, and we know where a cave is located. But to know the temperature of the cave, we have to do more than just point the thermal camera at it. We're limited by the camera's resolution, or the size of the area that makes up one pixel. The pit only makes up about a fifth of the images from the Diviner camera. So to get the actual temperature of the pit, the research team had to do a bit of math. They used mathematical models of the area contained within that single pixel. They knew that the temperature reading in the pixel had to be a combination of the temperature in the cave and the temperature outside, plus some weirdness from the motion of the spacecraft. The temperature outside the cave is dependent on topography, sunlight, and a bunch of other parameters, all of which can be built into a computer model. And the motion of the orbiter is pretty well understood, so the researchers could take that information and look at the differences in the pixel's temperature reading, and compare that to predictions of what the temperature would be if the cave wasn't there. Any difference is probably coming from the cave's temperature. It's like how you can get different colors by mixing paints. If someone hands you a tub of green paint and tells you they made it by mixing two colors, you can probably guess that the colors are blue and yellow. This model is a bit like working out the exact shade of yellow they started with if you know the exact shade of blue. The team found that the cave maintained a temperature of about 17 degrees Celsius, basically perfect for human habitation. That overhang might be the reason. It not only blocks incoming solar radiation during the day, it also prevents the heat from escaping at night, keeping the cave at a constant temperature. One big caveat here is that we're only looking at this from orbit, so while we have some idea, we don't really know what we'll find on the lunar surface. Of course, temperature isn't the only hurdle to lunar living. Low gravity and lack of oxygen are still a thing, but caves could also provide some protection from cosmic rays, harmful solar radiation, and other threats. That means that if humans really are going to live on the moon, lunar caverns might just be the place to start. SciShow Space is the place to start.